Hello everyone, my name is Aditi and my team members Ansh and Vaishnavi. The topic of our presentation is a wearable low power health monitoring instrumentation based on a programmable system on chip. Next, so this will be the content throughout the presentation. So let's start with the introduction. Improvement in quality and efficiency of health and medicine at home and in a hospital has become of paramount importance. The solution of this problem would require the continuous monitoring of several key patient parameters, including the assessment of autonomic nervous system activity using non-invasive sensors, providing information for emotional, sensorial, cognitive, and physiological analysis of the patient. Recent advances in embedded system, microelectronics, sensors, and wireless network enable the design of wearable system capable of such advanced health monitoring. Health monitoring can be improved by this ANS system. In a research paper, a system compromising a small wrist device connected to several sensors for the detection of the autonomic nervous system activity. It offers monitoring of skin resistance, skin temperature, and heart activity. It is also capable of recording the data on a removable media or sending it to a computer via wireless communication. Next, methodology. This is the basic system architecture. The wrist device is based on the programmable system on chip from Cypress. Programmable system on chips are mixed signal arrays with dynamic configurable digital and analogical block and an 8-bit microcontroller unit core on a single chip. This system is mainly based on the programmable system on chip. It is composed of a 8-bit Harvard architecture microprocessor. Um, then the analog blocks based on a configurable operational amplifier structures perform sensor interfacing and analog signals processing. The digital blocks based on a configurable digital structures are used to create timers and communication interfaces. A wireless communication is achieved by an Zigbee RF module. This module meets the specifications necessary for wearable application with low power consumption resulting from Zigbee Pro. It facilitates the implementation of short-range wireless communication. Embedded storage completes the embroidery features with the ability to record data on micro SD card. Currently, the smallest removable medium with the acceptable storage capacity. Next, Vaishnavi will explain.
Now we will see how system on chip is basically used in the proposed system. The ECG signal from sensors in the limited configuration which passes through the RFI filter to the input of high common mode rejection ratio instrumentation amplifier in order to eliminate the noise. To improve noise immunity in the ambulatory context, the driven right leg circuit is implemented, which is also the innovative concept used over here. From the output of INSAMP, the signal passes through the high pass filter external to the PSOC. Then the heart rate variability and the skin resistance responses are the main indicators for non-invasive emotional analysis. Although skin resistance is indicative of emotional, sensorial, and the cognitive stimuli, this response is also affected by the thermoregulations and extreme conditions like the weather changes. And this example demonstrates the need of retrieving information which is concerned to the subject's environment. Skin temperature provides information on vasoconstriction and it is also representative of environmental temperature. The above three signals therefore need to be continuously monitored. Electrodermal responses are obtained by measuring skin resistance. In this system, the potential difference is measured between electrodes, which results in the constant current injection. Thus, the measured voltage Thus, the measured voltage in an image of the skin resistance. Electrodes used for measuring skin resistance are around mercury and mercury chloride disc. The hydrogel pad was placed in between the skin and the electrode in order to improve the contact and to avoid the skin progressive moistening. Next, skin temperature was measured using the beta thermistor, which is named as 10K3A1. Resistance changes were converted into the voltages through simplified Wheatstone bridge network, and the bias resistance, which is used, have the value of VDD by 2, which is chosen in order to center the voltage scale. By selecting the same reference for the programmable gain amplifier, the second part of bridge becomes unnecessary, which further reduces the number of discrete components. Yeah. Further will be explained by Ansh.
Innovative concept. In this project, driven right leg circuit was implemented to improve noise immunity. It is often added to biological signal amplifiers for reducing the common mode interference. Skin resistance or skin temperature was not considered while considering human health as earlier, but this project does emotional analysis using heart rate variations (HRV) and skin resistance responses. Electrodermal responses are obtained by measuring skin resistance. What this project does, it monitors the signals continuously. So even if there are environmental conditions, it does not affect skin resistance, which indicates emotional, sensorial, and cognitive stimulus values. Next, limitations. The proposed system works well when considered hard measurements like ECG or skin resistance or skin temperature measurement. But when it comes to critical states like stress or mental health, it does not provide any indications. In real time, it requires low CPU consumption in order to be embedded on PESOC architecture. As there are limited number of analog blocks, amplification, filtering, and on analog to digital conversion is reduced. Next, results. The correlation between signals from the system and galvanic skin response GSR amplifier is 0.75, which matches closely to the performance of an immovable instrumentation. ECG was stable and ineffective of patients doing exercise. Without it being recharged, the system can work for almost 4 days. Next, conclusion. So we discussed the wearable health monitoring system based on system on chip, which focuses on ambulatory aspects. It has various applications such as health monitoring during driving under extreme conditions like for firemen during sports and even at home. Next, thank you.